there is a place in the universe where almost nothing exists. Not a black hole, not a dead star, not a frozen planet drifting alone in darkness. Nothing. Imagine taking the Milky Way, with its hundreds of billions of stars, and placing it inside a region of space so vast that it would still look empty. That place is real. It's called the Boötes Void. Discovered in 1981, this region spans roughly 330 million light-years across. To understand how massive that is, consider this. Light, the fastest thing in the universe, would take 330 million years just to cross it. Inside that space there should be thousands of galaxies. Instead, astronomers found almost none. At first they thought it was a mistake. Telescopes miscalibrated, data incomplete, a statistical fluke. But the more they looked, the more real it became. The Boötes Void is not just empty, it is unexpectedly empty. And that's what makes it disturbing, because the universe is not random chaos. On large scales it forms what scientists call the cosmic web, an enormous structure of filaments made of galaxies and dark matter, stretching across billions of light years. Matter clusters together. Gravity pulls structures into existence. Over time, the universe becomes patterned. Dense regions, clusters, superclusters, filaments, and between them smaller voids. Voids are normal, but the Boötes Void isn't small. It's one of the largest known voids in the observable universe, and its size breaks expectations. Based on our models of cosmic structure formation, regions that large shouldn't exist without containing significantly more galaxies. Statistically, something that empty over that volume is rare, suspiciously rare. Think of it this way. If you were mapping a forest from above and suddenly found a circular clearing the size of an entire country, completely devoid of trees, you wouldn't just say, "That's nature." You would ask what happened there. A fire? A disease? Something that cleared it out? The Boötes Void feels like that clearing. A cosmic absence. An absence is harder to explain than presence, because something has to prevent matter from accumulating. Something has to stop gravity from doing what it always does, pulling things together. Which raises an uncomfortable possibility. What if the universe isn't as evenly structured as we think? What if there are regions where the rules didn't play out normally? Or worse, what if something disrupted the natural process of galaxy formation in that region? Astronomers have found around 60 galaxies inside the Boötes Void. That might sound like a lot, until you realize there should be thousands. It's like walking into a city that should have millions of lights, and finding only a few flickering windows. The rest is darkness. And the deeper we look into space, the more we realize something unsettling. The universe is not just filled with matter, it is defined by what's missing. And the Boötes Void is one of the largest missing pieces we've ever found. The question isn't just how empty it is, the question is why. To understand why the Boötes Void is unsettling, we need to understand how the universe is supposed to work. After the Big Bang, matter wasn't evenly distributed. Tiny fluctuations, almost imperceptible differences in density, were amplified by gravity over billions of years. Where there was slightly more matter, gravity pulled in even more. Where there was slightly less, matter slowly drained away. This process built the cosmic web. Galaxies didn't form randomly. They formed along filaments, like glowing threads, connected in vast networks stretching across the universe. Between those filaments, gravity pulled matter outward, leaving behind empty regions, voids. So yes, voids are normal, but normal voids are part of a pattern. They are shaped by surrounding filaments, they have structure at the edges, they exist because matter migrated elsewhere. The Boötes Void, however, is extreme. It's not just a gap between clusters, it's a colossal underdensity, far larger than most cosmological simulations predicted when it was discovered. And that's where the discomfort begins, because when something doesn't match the model, scientists have two options. 1. The model is incomplete. 2. The observation is unusual but statistically possible. So which is it? One explanation is simple probability. In a universe this vast, even rare statistical fluctuations will occur somewhere. If you roll enough cosmic dice, eventually you get an extreme result. The Boötes Void could just be that, an improbable but natural outlier. But there's another layer to this. The universe expands. Dark energy accelerates that expansion. Over time, structures become more isolated. Some researchers suggest that massive voids grow larger as surrounding matter clumps more tightly into filaments. The emptier a region becomes, the less gravity it has to pull new matter in. It becomes self-reinforcing, an emptiness that feeds on itself. But even then, the scale is difficult to ignore. Imagine draining a lake slowly over time. You'd expect shallow water first, then patches of exposed ground. You wouldn't expect a perfectly carved crater hundreds of miles wide, with almost nothing left inside. Yet that's what the buoy's void feels like in cosmic terms. And here's where it gets interesting. Some cosmologists have speculated that extreme voids can influence how we measure the universe itself. Light traveling through massive empty regions behaves slightly differently. It stretches, it shifts. Meaning, where we observe voids, we may also observe distortions in our understanding of cosmic expansion. In other words, emptiness isn't neutral. It changes things. And that opens a subtle but profound question. What if the buoy's void isn't just a missing region of galaxies? What if it represents something about the early universe that we still don't fully grasp? A fluctuation larger than expected, a relic of inflation, a scar from conditions we barely understand. Because here's the truth, we assume the universe is statistically uniform on the largest scales. But assumptions in cosmology have been wrong before. And if a region this massive can exist with so little inside it, then maybe the universe is less predictable than we think. Maybe structure isn't guaranteed, maybe balance isn't permanent, and maybe what looks like emptiness is actually a clue. The buoy's void doesn't break physics. It doesn't violate known laws, but it challenges our comfort. Because when we imagine the universe, we imagine something full, dynamic, structured, alive with galaxies scattered in every direction. The cosmic web gives us that reassurance. Filaments connect everything. Matter organizes itself. Gravity builds complexity. The buoy's void interrupts that picture. It's a reminder that the universe is not uniformly vibrant. There are places where structure almost failed to happen, and that realization does something subtle to the way we think about existence. Because we evolved in a dense region of space, inside a galaxy, inside a cluster, surrounded by light. But what if we hadn't? Imagine a civilization forming inside a region like the buoy's void. Their night sky wouldn't reveal thousands of distant galaxies. Their telescopes might show almost nothing beyond their local group. No clear evidence of the cosmic web. No overwhelming display of large-scale structure. Their entire understanding of the universe would be different. They might conclude the cosmos is small, or static, or uniquely centered around them. In other words, emptiness shapes perception. And that leads to a deeper idea. The buoy's void isn't just a region of missing galaxies. It's a demonstration of how uneven reality can be on scales we struggle to imagine. The universe does not guarantee symmetry. It does not guarantee balance. It does not guarantee that every region gets equal structure. And if that's true on cosmic scales, what else might be uneven? What other assumptions about uniformity are we making simply because we live in a privileged region? There's also something psychologically unsettling about vast emptiness. We fear black holes because they consume. We fear supernovas because they explode. But emptiness? Emptiness does nothing. It simply exists. Silent, indifferent, enormous. The buoy's void is 330 million light-years of almost nothing. No explosions. No dramatic phenomena. Just absence. And sometimes absence is more disturbing than destruction. Because destruction implies action. Emptiness implies indifference. The universe didn't need to clear this region out. It simply never filled it. And that subtle difference matters. It suggests that structure, galaxies, stars, even life, may not be inevitable. They may be localized accidents, rare pockets of complexity surrounded by overwhelming nothingness. When we look into the buoy's void, we aren't just seeing empty space. We're seeing the possibility that the universe could have looked very different, that our galaxy didn't have to exist, that structure didn't have to win over emptiness. And maybe the most unsettling part is this. The observable universe is only a fraction of what exists. If something this vast and empty can exist within what we can see, what lies beyond it? More structure or more silence? The buoy's void doesn't scream danger. It whispers perspective. And once you understand how much of reality is defined by what's missing, you never look at the night sky the same way again. For more curiosities and mysteries of the universe, like and subscribe to the channel.